In this video, we will look at how to find conditional probabilities with the use of contingency tables. In our first example, we will look at a relapse study in which researchers randomly assigned 72 chronic users of cocaine into 3 treatment groups. The first treatment group used disipramine, which is an antidepressant. The second treatment group used lithium, which is a standard treatment for cocaine. And the third treatment group used a placebo. The results of the study are summarized below. One thing I want to point out about the table is notice that we are looking at categorical variables in this case with nominal values. So in the columns, we have whether the patient relapsed or not, and in the rows, we have the actual treatment that was used for the patients. So the first of 2 concepts that we need to discuss related to a contingency table when calculating a conditional probability is this idea of marginal probability. So we're going to illustrate that by answering the following question. What is the probability that a patient relapsed? Well, to find that, we take a look at the relapsed column of the table, and we go to the margin where we have these subtotals shown for relapse patients, no relapse patients, and then the total. That's why this is called a marginal probability, is because we're looking at values on the margins. And we see the number of patients that relapsed is 48. And then, of course, that was out of a total of 72 patients. So the probability that a patient relapsed is equal to 48 out of 72, or approximately 67 hundredths, which could also be expressed as 67%. So the second of 2 probability concepts related to a contingency table that we need before discussing conditional probability is this idea of joint probability, and that's illustrated by the following question. What is the probability that a patient received the antidepressant disipramine and relapsed from their treatment? Notice that when we say joint, that's characterized by the word "and" in the problem question that I just read. We're also still looking at a probability out of the, we're looking at a probability that's calculated out of the total number of patients. So in this case, a patient receiving the antidepressant disipramine would be in the first row of the table, and then the relapsed is the first column. Notice where those 2 intersect. So the joint probability in this case would be the 10 patients that received disipramine and relapsed out of the total number of patients, which was 72. So the probability of relapse and using disipramine for treatment is 10 out of 72, or approximately 14 hundredths, which again could be expressed as 14% chance that they relapsed and used disipramine. Now that we've talked about how to find marginal probabilities and joint probabilities with a contingency table, let's use those 2 concepts to define a formula for finding what's called conditional probability. So the conditional probability of the outcome of interest event A given condition event B is calculated as follows. First, notice the notation on the left is conditional probability notation. In other words, the probability of event A given, that's what the vertical bar means, is the word given that event B was true. Okay, so the formula is the joint probability of A and B divided by the marginal probability for B is equal to the conditional probability of A given that B occurred. Now we're going to use the contingency table below, which I've reproduced, and here's the example we're going to look at for finding the conditional probability of somebody relapsing given that they were treated using disipramine as their treatment for trying to recover from using cocaine. So the probability that someone relapsed given that they were treated using disipramine is equal to the joint probability of a patient relapsing and having been treated with disipramine divided by the marginal probability of a patient being treated with disipramine. Now from the previous 2 slides, we know that the joint probability for a patient relapsing and using disipramine as their treatment was 10 out of 72. And then we know the marginal probability for a patient having been treated with disipramine was 24 out of 72. So the probability of a patient relapsing, given that they used disipramine, would be found as 10 out of 24. Now I want to close by noting that even though I used the formula here to find this probability for the conditional case of a patient relapsing given that they used disipramine, we would rarely use the formula to do this. We would use a more intuitive method, looking just at the rows and the columns, which I'm going to demonstrate on the next slide. Now let's see if we can find the same conditional probability we found on the previous slide using the formula, but let's do so a little more intuitively directly from the contingency table. So if we know that a patient received the antidepressant disipramine as their treatment plan, in other words, that's the condition that we're given, what is the probability that that patient relapsed? Well, since the given condition is that the patient was treated with disipramine, that means we can focus on the first row of the contingency table, which is the disipramine treatment row. Then we take a look at, within that first row, how many patients relapsed, and we see that there are 10 of those. Now, because we're focusing only on the disipramine treatment, we only look at the total being 24 patients in that particular case. And so the probability that a patient relapsed, given that they used disipramine for their treatment plan, is 10 out of 24. Notice how easy that was to calculate. We didn't need the formula like we did on the previous slide to find that same exact value that we found previously. That value is also approximately 42 hundredths, or 42%. Now, let's take a look at another example. Let's switch the condition and the probability that we're looking for around. In this case, our given is that we know that a patient relapsed. So notice that that's going to mean that we will be focusing on the first column. Now we ask, what is the probability that that patient received the antidepressant disipramine for their treatment? Well, we take a look at how many patients used disipramine in the relapse column. There were 10 of them, and we see that that's going to be out of the total of 48. So the probability that someone was treated with disipramine, given that they relapsed, is 10 out of 48, or 21 hundredths, or approximately 21%. And again, I just want to point out how much easier that is to calculate that conditional probability from the contingency table compared with what we did using the formula. Let's now use the concept of conditional probability to talk about a general multiplication rule. You may remember that in section 3.1, we saw that if two events are independent, their joint probability, that is, the probability of A and B for two independent events, was simply the product of their individual probabilities. In other words, it was equal to P of A times P of B. Now, if the events are not believed to be independent, the joint probability is calculated slightly differently, and I've shown the formula on the slide below. So if A and B represent two outcomes or events, then the joint probability of A and B is equal to the probability of event A given event B times the probability of event B. Notice that what this is saying is the joint probability is equal to the conditional probability of A given B times the marginal probability of B. This is nothing more than the formula that was given a couple of slides ago, rearranged. It's useful to think of event A as the outcome of interest and event B as the condition. Let's take a little closer look at the concepts of independence and conditional probabilities to see how they're related to each other. So consider the following hypothetical distribution of gender and major of students in an introductory statistics class. We start by taking a look at what is the probability that a randomly selected student is a social science major. This would be a marginal probability. We see that the total number of social science majors is 60, and that is out of the total number of students, which was 100. So the probability that a randomly selected student is a social science major would be 60 out of 100, or 60 hundredths, or approximately, or 60%. Now, moving on, let's take a look now at finding the probability that a randomly selected student is a social science major given that they are female. Now, notice that this is going to be a conditional probability. So the condition is that we are limiting our attention only to looking at the student that was selected being female. And we see that out of the total of 50 females, 30 of them were social science majors in that case. So the probability of a randomly selected student being a social science major, given that they are female, is 30 out of 50, or 6/10, or again, 60%. Now let's take a look at one more probability. What's the probability that a randomly selected student is a social science major given that they are male? So in this case, we're focusing our attention on the male row of the contingency table. And we notice that in that row, there are 30 students that are social science majors. So the probability that we are looking for, the conditional probability we are looking for, is 30 out of 50, which is 6/10, or again, 60%. Now, having looked at all three of those different probabilities, we notice the following. Therefore, since the probability of a randomly selected student being a social science major, given that they were female, since that's equal to the probability that a randomly selected student is a social science major, given that they are male, and that is equal to the probability of a randomly selected student being a social science major, then the major of students in this class does not depend on their gender. So how would we summarize what we've just looked at? Well, generically, if the probability of event A occurring given that event B has occurred is equal to the probability of event A occurring, then the events A and B are said to be independent. Conceptually, what this means is giving event B as a condition doesn't tell us anything about the probability of event A occurring. Mathematically, we know that if events A and B are independent, then the joint probability of A and B is equal to the probability of A times the probability of event B. Then, in that particular case, the conditional probability of A occurring given that event B has occurred is equal to, from the formula we found on the slides a while ago, the joint probability of A and B over the marginal probability of B. And if we're talking about these events being independent, then the joint probability is just P of A times P of B. We then notice that the probabilities of B in the numerator and the denominator cancel out, and it tells us that we just are left with the probability of A occurring. We're going to go ahead and stop at this point in the presentation since we're not covering Bayes' theorem in section 3.2, and that concludes our look at conditional probability from the textbook using contingency tables.